Do you really need to go all in on the Max compared to the M1 Pro or even the base M1? The M1 Max, this is a video about the M1 Max, did the ultra high def export in under a minute 10. I did mention the new M1 Max-based MacBooks are fast. Wait, did it just hard lock? I'm excited. Apple's released their first MacBook Pros based on their in-house CPU-GPU system-on-a-chip designs, which it's calling the M1 Pro and M1 Max, and I've rerun the benchmarks I ran against the original M1. The thing that's most exciting with these laptops now is that we can start to draw some lines regarding their evolutionary and performance trends. So we'll take a look at that, even if it's still a bit foggy at this time, as well as specifically their darktable performance. But unlike with the original M1, personally what I want to know is how well will these handle DaVinci Resolve so I can render these videos quicker. I've been using the previous MacBook Pro with the Radeon 5500 mobile GPU and an external Radeon 5700 GPU to render the videos so far. The last 3 videos for reference took between 13.5 minutes for That's a Wrap and almost 31 minutes for the iPhone comparisons. The M1 Max with its integrated GPU was almost twice as quick with the wrap video, finishing in under 7 minutes and shaving 6.5 minutes off the render time. While the iPhone video also only saved 6.5 minutes, which, while 20% is a nice gain, it's not as spectacular as 50%. So what's going on, and what sort of performance gains should you expect from the M1 Max? And where won't you see those gains? Do you really need to go all in on the Max compared to the M1 Pro or even the base M1? This video will take a broad look at system performance. We'll specifically compare the M1 Max with what it's most directly replacing, the 2019 16-inch MacBook Pro with Intel's 9th generation 2.4 GHz Core i9, as well as with the earlier M1. We'll look at how well the respective CPUs and GPUs perform, but more importantly, we'll look at how well the overall systems perform, and based on that, I'll give some observations specifically for 4 main categories. Video editing, especially with DaVinci Resolve or Final Cut Pro, photo editing and darktable, software development, and generalized basic office work, web browsing, and watching these videos on YouTube. So, let's get started. The M1 Max is really fast. It's a complex system on a chip with optimized subsystems made from 57 billion transistors. It can get hot, and we'll talk about that in a bit. But what reviewers have found is that the M1 Max is a fast, number-smashing machine. Before we get to the benchmarks, if you just want the bottom line, get the M1 Max. You're obviously too impatient to understand the differences, and you think your workload is too demanding for the M1. So if you don't have the compatibility issues with macOS running on Apple Silicon, just get the M1 Max and be done with it. Maybe save some cash by not getting the 8TB SSD, but whatever, your time is money, and I've just cost you an additional 30 seconds. Thanks for watching, and for everyone else, that's a pretty good summary of the device with which I'll end. Most people probably don't need the 64GB of RAM or 8TB, but if you're looking to get something more than the base M1, I think the M1 Max is going to be a good move over the Pro, but we're getting ahead of ourselves, and I feel it's necessary to take a step back and point out that this is actually my second video on Apple Silicon. I had an earlier video focusing on photo editing performance, comparing the x86-64 and Apple M1 using darktable, and speculating about how the architecture might scale up. Now, I wouldn't say that my thesis has been rendered invalid. To the contrary, I think the principal thesis is actually supported by the M1 Max, that for raw power, high-end AMD and x86 systems will outperform Apple systems. But by focusing on one isolated test, the specific recommendations coming out of that video lacked context. And to be clear, 2-year-old mobile laptop chips are not what I mean by high-end. The M1 Max will hold its own, if not excel against its predecessor in pretty much any practical test. These are the type of benchmarks that I actually find interesting. I think it's boring to test 2 similar chips. Who really cares how the same generation Core i9 does against the Core i7? You can get the gist from the spec sheet. When we're looking at different architectures with fairly different approaches, there's a lot less we can be sure of a priori. Apple has aggressively removed distance between critical components of the computer and taken the approach of removing bottlenecks rather than creating components that are absolutely top performers. Copying data in and out of RAM is slow and inefficient. Use a unified memory model. Video encoding decoding is hard on the CPU. Yet, Apple caters to video creators. Use dedicated silicon. The M1 bus is getting saturated as you push the CPU. Go to the M1 Pro, it's got 3 times the bandwidth. You can fully utilize the GPU and CPU. Need more GPU power? No problem, add more cores. Hitting that bandwidth ceiling again? Never fear, the M1 Max is here with plenty of bandwidth so that you never have to worry about that again. You can even double the cores to 32 without having to worry about bandwidth. Apple has more room to grow the GPU and CPU cores with the current system, but it's not clear how long they can keep this up. The current expectation is that the version of the M1 that would appear in a Mac Pro would be 2 interconnected M1 Max chips. The interesting thing about that, based on Anatech's analysis of the M1 Max CPU and its performance, is that there's plenty of bandwidth available on the M1 Max. Of the 400 gigabytes a second available, They could only get the CPU to utilize 60% or about 246 gigabytes a second. And while the CPU isn't the only thing that's accessing memory, the GPU is another important high bandwidth contender. It seems there'd be plenty of bandwidth, enough bandwidth to handle some fetches from further away memory, like that of a second die expected in the first generation Apple Silicon Mac Pro. Earlier rumors also pointed to a system of 4 interconnected M1 Maxes, maybe the M1 Max, so who knows outside of Apple HQ. There's no such thing as a perfect general purpose benchmark when you're testing a complex system like a modern PC. That's especially true when you're looking at significantly different architectures like those of Intel's x86-64 based laptops and workstations compared to Apple's ARM64 system on a chip based general purpose personal computers. Depending on the specifics of the workload, you may hit different bottlenecks. One system may be significantly faster in video editing for someone posting to YouTube, working with 1080 or 4K single stream H.265 video with basic color corrections, but fall down if you're working on 6K or 8K with VFX and highly compressed RAW files. All you can say for sure from the results alone is, for a given workload and a given program or set of programs, one system was better. Even then, one system might, in theory, be significantly faster, but if a practical workload would be unlikely to actually take advantage of that potential performance, there isn't really a benefit to the user. And that brings us back to our initial numbers. What's going on there? Well, rather than try to dig into what's going on with those specific videos, I created a dummy video recorded on two BGH1 cameras, similar length with a slightly different angle, but the principal difference is that one was recorded in H.265 optimized for file size, that is encoded as a long group of pictures, and one for editing, that is all interframe encoding. The long group of pictures also outputted the BMD Video Assist, which recorded ProRes 422. All the files were captured in Cinema 4K at 24 frames per second in 10-bit Panasonic Vlog. For each of those inputs, I rendered 5 56-second videos. There's a baseline video, which is effectively reading in the stream, doing a color space transform, then encoding it as H.265 before running the file. This is pretty close to a null op and should show pretty close to the maximum throughput of the system. The other tests get progressively more complicated, but they all start with the ultra high def or UHD or 4K timeline. This takes the baseline video and over the first few seconds adds in additional copies of the same stream, each with a different color effect or grade added, just in case DaVinci tried to get smart and use cached renderings, which it didn't seem to do anyway. There are some interesting results that come from this test, but we'll get there in a moment. The remaining 3 tests all share a timeline, but vary in their export parameters. The UHD test exported to H.265 and all told had 4 streams. The 3 remaining tests created an 8K timeline, with 4 copies of the UHD timeline each taking up a quarter of the screen. The first test would output to 8K to H.265, the next would output 8K to ProRes proxy, and the final test would output to H.265 again, but downsampled to ultra high def 4K. Right, so what can we learn from these? Let's start with the most basic, the baseline test, which gives us an idea of the fastest we can expect DaVinci Resolve to work. And on these clips, we see absolutely no difference between the 3 different 2019 Intel configurations, the Radeon 5500 Pro, Radeon 5700, or both of them as a dual card configuration. Both cards have the same generation of AMD's Video Core Next 3.0, and doubling up doesn't provide any improvement. If you bought a later model of the 2019 16-inch laptop, you would have had the option to upgrade to the Radeon 5600. That card would likely give you a small bump in performance similar to that of the 5700 eGPU, and pair better with the eGPU for dual card rendering. But again, you wouldn't see any improvement here in the baseline test. I should also note that there's a lot of variability in these tests. You should expect error bars of about 10% on a given run. In each case, I've taken the fastest time without dropped frames, a caveat that only applied to the M1 Mini with its 8K output tests. The baseline tests are likely on the lower end of that error bar, and so I can say that the AMD GPUs on Intel are in fact slower than the M1 at encoding H.265. I didn't do any quality analysis on these tests, but the output is all good enough for YouTube work. And the M1 Max smashes them both, completing the nearly minute-long output in only 10 seconds. As we move on to the more complex exports, let's talk about ProRes first. The difference between the file formats is a topic for another video, but ProRes is designed to be an efficient working codec. It's the default working that is proxy codec on macOS for both DaVinci Resolve and obviously Final Cut Pro, which originated the format. And it's being increasingly used for acquisition from external recorders like the BMD Video Assist or Atomos Ninjas, a select few cameras which record internally, the DJI drones, the new Nikon Z9, and also the latest iPhone Pros. It, unsurprisingly then, has the best performance for Intel and AMD-based systems. The internal Radeon took 9.5 minutes with the highly compressed high-efficiency video codec encoding, but tore through the ProRes 422 in under 3 minutes. The all-interframe version of the high-efficiency video codec was almost as good, taking 20 seconds longer than the ProRes. The eGPU Radeon was faster, but the same pattern holds. It even holds as we move into the more complex timelines, albeit playing a smaller role in the overall time needed to render the videos. Comparing the ultra high def rendering time, we see that the 2019 MacBook Pro is able to utilize the eGPU to reduce the overall rendering time by over a minute, from 242 down to 135, while using both GPUs provided only a small improvement from there. The M1 Max performed even better. It rendered the video in nearly real time with all 5 ProRes streams and basic color effects, rendering in 1 minute 7. What about the base M1? It took about 3 times as long as the eGPU, or 4 minutes and 22 seconds. So the $6,000 Intel-based MacBook Pro beat the $600 Mac Mini. Well, as I mentioned above, benchmarks only tell part of the story. Many people are capturing an H.265, and while you may or should care about ProRes performance, since it's probably being used internally as you edit, exporting is going to go back to the source files for maximum quality, and this is where we see exactly what Apple is targeting with these systems. The 2019 MacBook Pro took less than 3 minutes to process the ProRes, but took over 9 minutes to process H.265 long group of pictures. The M1 took 422 to process the ProRes, and took 428 to process the H.265 long GOP. That's right, no practical difference in processing time between ProRes and H.265, both of which have hardware acceleration on the M1. So you may be going from twice as slow with the ProRes to twice as fast with H.265. The M1 Max, this is a video about the M1 Max, did the ultra high def export in under a minute 10. I did mention the M1 Max was fast. Moving up to the 8K files, which took 4K timeline and put them in each quadrant for a total of 16 concurrent streams of the source file. This was designed to push the hardware decoders. There were 3 versions: exporting a ProRes proxy at 8K, exporting H.265 at each of 8K, and finally 4K. The 2019 MacBook Pro did the ProRes export in just under an hour with each of the Radeon 5500 and 5070 GPU, and was able to effectively use both of them to export in 28 minutes 50 seconds. Output to 4K 265 was a little slower than 8K ProRes, just over an hour with a single card and just over 30 minutes with both cards. With 2 GPUs, it's not surprising that the M1 fell further behind. Just as the ultra high def timeline, the M1 completed the 4K 265 export on the 8K timeline in about twice the time taken by the Radeon 5500, or now 4 times longer than the dual GPU setup. 2 hours, 24 minutes. The M1 Max took 16 minutes. 16 minutes, well, ranging from 1555 for the 8K ProRes proxy export to the H.265 all-intro encoding of 1613 for the 8K timeline exported as 4K 265 from either 265 long GOP or ProRes, basically 16 minutes. That's half as long as it took the 2019 16-inch to do it with 2 discrete graphics cards, or 4 times as long as it took with the internal Radeon card alone. Well, we haven't talked about the 8K 265 export. Both ProRes and H.265 export are accelerated on the M1 Max, and they both churn through 8K streams with aplomb. The ProRes encoding was slightly faster than the 265 encoding, but the H.265 export was effectively the same speed at either 8K or 4K. The AMD chips couldn't do 8K H.265, meaning the CPU was tasked with that chore, and that process took about 2.25 hours, or 2.5 with the H.265 long group of pictures source file. The M1 was unable to process the 8K video as 8K 265, and the 8 GB of RAM led to memory pressure in addition to a fully worked GPU during all the 8K testing. These M1-based machines are optimized for video, and that's their bread and butter. That's their target audience, and the M1 Max with the extra media processors highlights that. The community of DaVinci Resolve users has historically used the standard Candle benchmark for DaVinci Resolve, with standard Rocket recently being used as well. The latter originated on the Mac Rumors forums and has since been used by Anatech in their analysis of the chips. My own results mirror those already published, although there was one interesting bit that, depending on how you look at it, either the system quickly throttles the GPU, or there's a brief burst of turbo. I noticed a 10% difference in the GPU performance, with it throttling down 10% after a sustained workload. Pretty quickly, for that matter. I'm guessing, but can't confirm, that the originally unannounced high-performance mode of the 16-inch M1 Max MacBook Pro effectively removes this throttling, so you're always running at that, let's go with turbo rate. The distortion field isn't dead after all. The GPU performance follows what you might expect from the spec sheets. The M1 with its 8-core GPU has been estimated at about 2.6 teraflops, and maintained frame rate through the GPU-heavy blur and noise reduction nodes at about half that of the 4.5 teraflop Radeon 5500M. The eGPU, with its 7.9 teraflop Radeon 5700, does about 3 times the performance of the M1. And the 32-core M1 Max, with its estimated 10.4 teraflops, maintains a frame rate about twice that of the 2019 laptop and its Radeon 5500M. Based on benchmarks performed by other people, Mac Pro with 2 AMD dual cards will still outperform the M1 Max by another factor of 2. And if you're working with harder to process files or effects that need to run on CPU, you're not going to be able to completely replace a Mac Pro. However, the M1 Max based laptop should eat away at a large chunk of the low to mid-end Mac Pro market. Those who just want a smoother editing experience than was previously available with Apple's Intel laptops or iMacs. The excellent H.265 performance is encouraging to me personally, as it means I don't need to worry about the trade-offs between storage and editing performance for all-I or long GOP encoding. I can just stick with the more space-efficient long GOP and slower V30 SD cards, saving money both on recording and storage media. I mean, that's what I'm doing anyway, but now I don't even need to consider all-I. The CPU performance for a single core isn't any different than with the original M1, although we see the expected added benefit from the additional performance cores on work that's parallelizable. Building Firefox dropped from 21 minutes 50 seconds with the M1 to a second over 12 minutes with the M1 Max. The additional cores, RAM, and importantly SoC's ability to send data between them all helped out here, and both GPUs averaged above 95% utilization. For comparison, the Coffee Lake Core i9 averaged just shy of 94% utilization and finished in 26.5 minutes. So let's take another look at darktable performance, and as I said at the top, I've got a broader range of numbers with me this time. If you recall from the first M1 video, or not, it didn't get much traction, I was impressed by the GPU's performance compared to other integrated GPUs, but otherwise was unimpressed compared to the Intel MacBook Pro with their discrete graphics and the Core i9 CPU. In the words of John Flansburgh, forget what you've been told in the past. The Rosetta translation is pretty amazing, with bulk processing to JPEGs of the test set taking about an hour and 40 minutes, with both the M1 and Coffee Lake Core i9 when running on the CPU in batch mode. So they're about even. What I was looking at principally last time was the cumulative frequency distribution graph for processing the individual images. And we can see that the Intel chip tends to be faster than the M1 CPU, although the M1 GPU is faster than either of those CPUs, and the Intel Iris graphics were so bad I didn't even include them on the graph this time. We also see that asymptotically, as the processing gets more involved and the image is larger, performance deltas disappear, and the Rosetta performance gets more efficient if running through multiple images at once, rather than the one-offs of the darktable CLI. And regardless of all that, the M1 Max CPU was clearly faster than either, and as the processing got more involved, the 8 performance cores of the M1 Max and its 2 efficiency cores pull ahead of the 8-core M1 GPU. And this is where the results get interesting. On an image-by-image basis, the M1 Max CPU takes longer. Processing the images is clearly slower than the discrete AMD graphics, yet when processing a year's worth of images at once, the M1 Max CPU took just under 63 minutes, while the AMD 5500M only managed 77 1/3. The Radeon 5700 eGPU did in just under 53 minutes. I'm not entirely sure where the delta goes, if it's the generally faster SoC and RAM compared to the 2019 Intel system, or that Rosetta 2 makes better use of cache translations. I'm actually leaning towards the latter as being the bigger contributor, or both. For what it's worth, importing all 7,000 plus images took about 90 seconds with both generations MacBook Pros. Darktable only reads and stores metadata during input rather than doing any proxy conversions, unlike Adobe Lightroom. The M1 Max-based MacBook Pro also got quite hot repeatedly running Darktable CLI. In testing, the M1 Max laptop reached 109 degrees Fahrenheit here at the case, while the 2019 Intel machine reached 114 at its peak during the benchmarking when it was doing H.265 encoding in DaVinci. The GPU rendering never got that hot for the M1 Max, and its 32-core GPU, again, was remarkable. Looking at the graphs, it performed at the same level as 2 AMD graphics cards. Looking at the 2019 batch export, it only took 46 minutes, well, 45-57, exactly 7 minutes or 15% faster than the Radeon 5700 eGPU's best time. There are 2 takeaways here. First is that if you're running Darktable in single screen mode, the M1 Max will be among the fastest systems you could use. Performance is likely going to be slightly better in real-world usage than the benchmarking reported, more like the performance wins in the batch mode, but you lose the ability to assign different pipelines, like second monitor previews, to their own card. The second is that the M1 Max does get hot if you pressure the CPU. 109 degrees Fahrenheit, 43 centigrade is still pretty hot if you're working on your lap, although there were fewer cases that reached the peak temperature throughout the testing. Launching applications in Rosetta appear to be the most taxing thing to do on the CPU. If you happen to have any utilities which you call repeatedly in scripts, make sure you build them for Apple Silicon. The M1 Max is fast. The performance is actually on par with what I expected based on Apple's own benchmarks and what we saw with the original M1s, but actually seeing it perform at that speed, a more than 10% improvement in a generation of the MacBook Pro, it's still amazing to see, and I really wasn't prepared for it. I've only done some small work on the laptop in DaVinci Resolve so far, but anecdotally as it is, it feels more responsive and snappier. So what are my recommended configurations for the use cases at the top of the video? First of all, let's look at the configuration which I think makes the least sense, the 1016 M1 Pro. All variations of the M1 include a 16-core neural engine with the various flavors varying by SoC bus bandwidth, and within the Pro and Max flavors, a varying number of GPU cores, and in the case of the Pro at the base level, the number of CPU cores. For a $100 upgrade, the 1016 M1 Pro adds 2 additional GPU cores, or about 14% boost in graphics power. The next jump up adds a 50% boost in graphics cores to 24, but also moves to the M1 Max SoC with its greater bus bandwidth, and, critically, for more involved video editing, doubles the media encoders. A Mac Pro or other workstation class PC is going to serve you best for the heaviest workloads, and if that's what you're doing, hopefully you have the budget for it. For everyone else doing 4K or 8K editing, the M1 Max is going to serve you well. If you can afford it, max it out. But if you're looking to save money, dropping a 4TB SSD will save you $1,200 if you tend to work on only one project at a time, and especially if you tend to just work with H.265 files. The extra media decoding oomph of the M1 Max lets it work through heavily compressed H.265 files basically as well as it does with ProRes or interframe encoded files. In my own projects, 32GB of RAM is also the sweet spot. On the Core i9, 64GB helps when I'm running virtual machines for different purposes, but since the M1 doesn't support x86 virtualization in the same way, that's not an option. And even working in 8K, DaVinci Resolve has stayed at or below the 32GB limit. Together, that's saving $1,600 or a quarter of the price of a maxed out M1 Max. You could also consider dropping down to 24-core GPU, but I don't think the savings are going to be worth it for the loss of performance. With photo editing, specifically in darktable, I still think 32GB is going to be the sweet spot on RAM. If you're working on 24 megapixel or smaller images most of the time, you could get away with 16GB, but the base 8GB of the original M1 really is too little. Half of that's going to be used by the system and background tasks. Since the M1 Max starts with 32GB, that's the least you should expect to get because the added bandwidth of the M1 Max SoC is going to help. The choice between 24-core or 32-core GPU will be less obvious here, and honestly, it's going to come down to how much you value that $200. Practically, you may not notice a significant difference most of the time during interactive editing. When I first began looking at upgrading for darktable last year, and asking around in the darktable IRC channel, I was recommended a Ryzen-based system with a mid-range NVIDIA 3070 or 3080, but nobody explained the recommendation or where the various system stresses existed. I think I have a better idea now, and for what it's worth, it supports those recommendations. Most images aren't going to be able to maximize the power of a top-end NVIDIA card. 8GB of RAM on the card is a good minimum. Look at the last M1 video to dig more into that. And beyond that, there's going to be the speed of the RAM, CPU, and bus all playing a role. So there's my darktable recommendation isolation. A Ryzen or current Threadripper with a board supporting fast RAM, and a mid-ranged NVIDIA GPU, or two if you use darktable in dual monitor mode, running GNU Linux. Carried over to macOS though, that means an M1 Max with either 24 or 32 GPU cores. If you don't want to spend that money, even an 8-core M1 Pro with its 14-core GPU will be a big step up from the base M1, which itself will be better than an entry-level Intel machine with its integrated graphics. So those are my recommendations at 3 different price points. Unfortunately, there isn't a highly performing, fully open option for darktable at the moment. Gone are the days of open source ATI drivers filling that bill. The performance metric which surprised me the most was how efficient building, compiling, and assembling software was on the M1 and the M1 Max. I know Apple has championed its Xcode performance on these chips, but I don't know how well that would extend to an arbitrary cross-platform example. Obviously, if you do development for Apple iOS, iPadOS, or tvOS devices, any of these M1 flavors will be refreshing as the device simulators will be significantly more efficient than they were on Intel chips. Software development generally won't need the GPU power we're seeing here, but the increase in bus bandwidth, performance CPU cores, and RAM capacity will be beneficial. With that in mind, an M1 Pro or M1 Max makes more sense than the base M1, which is limited to 16GB of RAM. Obviously, the 1024 Max would be my first choice, but either of the 14-core GPU Pros would make sense as well if you're pinching pennies, but frankly, that seems pound foolish if you're in a professional situation. The same thing goes for memory. If you're settling on an M1 Pro, pick 32GB of RAM. Modern IDs are heavy, judging from people who look cross-eyed at my TMUX sessions filled with Vim. I thought they discontinued Emacs 15 years ago. One other important improvement over the base M1 for software development, the number of supported monitors. The original M1 only supported 2 displays, so 1 external display for a laptop. The M1 Pro can power 3 displays, the inbuilt Mac Pro display and 2 external displays, while the M1 Max can support 4 external displays, up to 3 6K screens and 1 4K screen, in addition to its inbuilt laptop display. I generally have 3 external screens connected, so for that reason, on top of everything else, I definitely recommend the M1 Max 1024 for software developers. And in all these cases, I personally like the 14-inch over the 16-inch. Apple was a little misleading during the presentation when they said the performance was identical. The 16-inch model later turned out to have a high-performance mode because of its improved cooling setup. But the 16-inch is just too large for a portable laptop, in my opinion. It's not as bad as the old 17-inch PowerBooks, but it is larger than its predecessor 16-inch. And the 14-inch laptops are some of the most portable laptops I've ever used, definitely the most powerful for its size. The base M1 is good enough for general business use, web browsing, video conferencing, watching YouTube, basic audio mixing, although I've been reminded that more involved sampling would benefit from additional RAM of an M1 Pro or the M1 Max. But basic office or home usage ought to be handled well by the M1. A 16GB, 1TB Mac Mini runs about $1,300, or a Mac Air at $1,600. The Mini has the advantage at having a standard HDMI port missing on all the other non-MacBook Pro machines, as well as supporting a second display over Thunderbolt. The setup will also be better than any entry-level Intel setup if you're doing any video or photo work. And in all cases, I'd recommend getting the 16GB of RAM. With 8GB, expect that to effectively be 4GB for the system and 4GB free for applications and file caching, which isn't a lot for macOS, and you'd be putting extra wear on the SSD being used for swap. But it will suffice for the lightest of workloads. When I'm not benchmarking it, my M1 Mac Mini just updates its software and streams audio into a DAC, something it handles without breaking a sweat or resorting to excessive swap. There we go. I think that covers all of the use cases I set out to cover, and a couple more that came up in conversation.
What about gaming?
Huh?
What about gaming?
This isn't really targeted gamers. Why would I test that?
If you look at the Compact Pro laptop on battery...
That's not the point of what he's saying. There aren't many laptops that have, mobile workstation graphics cards. You've got Asus's luggable, nearly 6.5-pound StudioBook 1, or, sure, there's the more manageable 4.4-pound StudioBook Pro, which is actually pretty close to the 16-inch MacBook Pro. But for the most part, people will be familiar with the more consumer cards.
Spinning cubes. Thousands and thousands and thousands of them. When you're making a game...
And that whole section of the video is aimed at professionals, people writing software, working with 3D models, professional tasks with graphics-intensive workflows.
Performance of these new Pro chips mean you can make more complex scenes, bigger games, better games, all on your laptop.
But fine. If the internet is really concerned with gaming, let's take a look at a couple of example games. Graphics performance was more than good enough to run BZFlag at full resolution on the internal display, and with full quality and effects enabled. Similarly, DOSEMU X installed fine from Mac ports, and Syndicate was as easy or difficult in the later levels to play as ever. Maybe I should have tested Satellite Rain instead, although it doesn't have the same acclaim as Syndicate, which was ranked the 11th best violent video game according to the Daily Telegraph, and which made UGO's list of the best ever video games. So the M1 Max is certainly good enough to play some of the best games ever created. Since it lacks x86 compatibility though, Wine and VirtualBox were out of the question, so I was unable to run any of the Ultima Online clients, but for online gamers, I had no problem logging into and playing on public NetHack servers. The machines were more than capable at rendering at speeds above 2400 baud, letting you ascend at a buttery smooth 120 Hz. Maybe I'm not the best person to be testing games on the M1. I currently have two laptops I use regularly. The 16-inch MacBook Pro from 2019, which basically operates plugged in at all times, even when I'm traveling. It's big, but it's the solution I have for graphics-heavy tasks. And an old ePC, which has a great keyboard for a laptop and a long-lasting battery, and which I use for everything else. Quite frankly, I was originally expecting to be disappointed and potentially even return the new Apple laptop. Its performance in non-linear video editing nixed that idea, and having this level of performance in a 14-inch laptop, built-in SD and HDMI ports, a battery rated well past 8 hours, a 120 Hz wide gamut 1000-nit sustained display, and a reasonable keyboard have made it a keeper. Are the new MacBook Pros worth the upgrade from earlier iterations? The general advice about if it works, and there aren't serious security issues about which you're concerned, don't upgrade holds. But there are some really nice improvements in the new models, and they begin with the aforementioned ports, meaning that these are a lot less cumbersome to bring with you when traveling. The return of MagSafe is a nice change. With kids or pets running around, its quick release process was a big step up from the pre-MagSafe connector. The USB-C adapters were less problematic, but I still appreciate MagSafe's return. They use the same transformers, but rather than having a USB-C plug on both ends, the laptop end has the new MagSafe connector. If you have a MacBook Pro which predates the 16-inch redesign, and you use the inbuilt keyboard, you should probably upgrade. The earlier Butterfly keyboard used between 2015 and 2019 was atrocious, and on top of that, less reliable. The return of a proper, physical keyboard, and retiring the promising, but in the end abandoned touch bar, harken the return of functionality as a feature. I'm not ditching the Intel laptop though, and I think this makes my next upgrade clear, which is to go back to a proper GNU Linux workstation. The lack of x86 virtualization instructions is a drawback, and at the moment there are, not hardware incompatibilities, but driver compatibilities, such as the OWC Thunderbay I bought to facilitate the transition between computers. Apparently the $5,000 cage they sell just exposes a bunch of disks and relies on a single-seat license to do software RAID. which of course makes it more cumbersome to move it between machines, and it's shipped with a version that doesn't even run on Apple Silicon, not to mention problems with macOS 11 generally. But storage, that's a different video. For the time being, the Core i9 will continue to be used for photo editing and the 14-inch M1 Max for video editing and travel, but there's no reason why the M1 Max wouldn't be able to handle the photo editing at least as well. The performance difference is just less pronounced. Beyond driver compatibility, is there a reason to avoid Apple Silicon right now? Well, at the highest ends, it won't do as well as x86 and multiple discrete graphics cards. The current Mac Pro is more expandable, and the discrete GPUs available are still more powerful. NVIDIA graphics cards and CUDA or x86 64 boards with greater than 64 gigabytes of RAM, those are all workflows in which Apple Silicon isn't competitive. Stepping aside from two options, macOS on Intel and macOS on Apple Silicon, it's worth noting also the third option, not macOS. There's no such thing as a secure, functional personal computer, and I continue to applaud Apple for their continuous improvements on securing their mobile devices, including laptops. Things like the T2 chip and integrated security modules on their own SoCs. You can disable these on their PCs, including their laptops, unlike their mobile devices, but whether you've got it enabled or not, fundamentally, you're still leasing a system in macOS which is owned by Apple, as evidenced by the fact that they'll hold your iCloud data hostage until you agree to changes in the terms of service. It's not as if they'll continue letting you access the data under the old policies if you decline any updates. Accessing your iCloud account, reinstalling, or even rebooting if you haven't disabled Secure Boot, all happen at the pleasure of Apple, so it's not without risks to utilize an Apple-exclusive ecosystem. Having some form of backup and file access you can access without Apple would be a wise decision. There are examples in B&H's reviews of the Mac Mini, for instance, where purchasers were unable to activate newly purchased computers. And in my own experience, I ran into an issue where I was unable to reactivate my Mac Mini for several hours after wiping and trying to do a reinstall after the last benchmarking video. Should that turn you off of macOS? Well, maybe. Maybe not. For a travel device, I'm willing to live with the risks, taking adequate backup precautions, and that's the purpose of the 14-inch MacBook Pro is going to be. So thanks for sticking through this. I know it's been a long video, or welcome to the end if you just jumped to get more information on the lockups I'm saying. The issue appears to be triggered through the M1 Max metal driver in some way. The good news is that means it'll probably be fixed in macOS update eventually. I was unable to reproduce the issue with the inbuilt Radeon Pro 5500M and the Intel-based 16-inch MacBook Pro. Again, this seems to be the M1 GPU driver, or at least isolated Apple Silicon. I have been successful in consistently triggering it when rendering a DaVinci Resolve project with some very specific settings. I'm still trying to build a second test case. If I get one, I'll post a follow-up, although I've whittled down the buggy timeline to better understand how to trigger or avoid the lockup. I've only been able to reproduce the lockup with one transition, although the settings and duration don't appear to matter. This may mean there's a bug in DaVinci Resolve's implementation of its foreground wipe, probably grabbing the dimensions from the wrong object somewhere, but regardless of that, there's clearly a bug in macOS, or the M1 GPU driver specifically, since an application shouldn't ever cause such a catastrophic failure that the UI shell dies, let alone the machine locks up. For background, I have a couple of clips that are from the BGH1 recorded in 10-bit vlog, but I don't think that should matter. They're all Cinema 4K at 23.98 frames per second. I originally had one clip that was in the H265 long group of pictures as the base, with a ProRes 422 from the BMD Video Assist on top of it, but I replaced the ProRes with the same clip from the BGH1 internally, so the file format doesn't seem to matter. On top of the longer base clip, I placed the secondary clip. I zoomed the secondary clip in so that it would be cropped into 16:9, so 1.08 works, split it, and then added a transition. Specifically DaVinci Resolve's Fusion foreground wipe, I did not crop the timeline. I intended to let DaVinci do that itself. There's one more thing. I need to include the timeline inside another timeline. Both timelines are configured as UHD 4K. Rendering the outer timeline is what causes the lockup. Rendering the inner timeline worked fine. Rendering the outer timeline with the base video track of the inner timeline disabled, only the transitioning secondary track enabled, worked fine. Not zooming the transitioning clip past the boundaries of the timeline worked fine. I tried several other transitions without reproducing the issue. This is just one more thing to consider, especially if you're buying this for the GPU power. For what it's worth, the Intel-based 16-inch does the render with just the internal Radeon 5500M in just under 39 minutes. The M1 Max, well, obviously doesn't do the export since it locks the machine, but changing just the transition, the render completes in 1738, so just under half the duration. At least the startup sound does sound particularly good on this generation MacBook Pro's internal speaker. As always, thanks for watching, and I'll see you next year.